Hi everyone, and welcome to another session. This time we will be talking about graph problems, more specifically on maximum independent sets. We will see more graph problems more in depth when talking about the QAOA algorithm. Um, but yeah, this time we will be talking about maximum independent sets. We will be seeing the different types of them, and we will solve one of those problems in or visualize it with the code helping us using help from the ways functions. So a bit of introduction that it's more definition than introduction. Within the graph theory, we call some graphs we call them independent sets. These independent sets is that they are some types of graph where we select some nodes that are not interconnected. So as you can see here, with one node selected, of course, with just one, we cannot interconnect it with anything. But with two, there's no direct connection between them. We should have a diagonal edge here that we don't have because this one it's not directly interconnected. We have here a node in between them, so this doesn't count as some connection. So have this. This is an independent set. This is a set with two nodes that are not interconnected between them. We can add another one. So we have three here, and we see that there is no direct connection between this one and this one, or this one and this one. Same way with these other two, and with the one in the corner with the two in the center. There is no direct connection. As before, this connection here doesn't count because there is a node in the middle. These are the independent sets. Embedded in that group of sets or of graphs, there are the maximal independent sets. Those maximal independent sets it's are the sets in which we have selected the maximum number of nodes without being interconnected. So as you can see here in those two examples, these are maximal independent sets for this kind of graph for two nodes. If we add a single one additional node, we can see here that it would be connected. So if we add one here, it would be directly connected with this one. Here, here, and here, these three, these two will be, and this one, these three, sorry, will be directly connected to this one in the center, and this one, and this one would be directly connected to this one. And this is just a rotation of this one. So as you can see, we cannot add one additional node or select one additional node without the graph not being independent. And then this really small group embedded in all of them. So they are independent sets, they are maximum independent sets, but they are called maximum independent sets. What is this? These ones are the ones that have the maximum nodes selected that are not interconnected between them. So here we have two, here we have four. That is the main difference. That is the maximum. It's the, let's say, if we want to embed the maximum number of nodes that are not interconnected between them in those graphs, these are the ones. So these are four, and they are not interconnected between them. This is just a rotation of this one again. These can be applied for formulating or modeling relationships between people, as in social networks, or knowledge graphs about, for example, workers in a company. Um, they can also be modeled as streets in a city, with the corners interconnecting different streets or different buildings. So yeah, it can be applied to several real problems. Then we have some other concepts such as the independence number G, that is the number of nodes. It's usually denoted as alpha G. Um, yeah, of all those problems, the maximum independent finding the maximum independent set in a graph is a NP hard problem. So those are the ones that we can find a solution or an advantage uh, with quantum computing. We cannot find it now, as you already know, but uh, we will be able to. And then is the click set problem. That is the complementary, just the opposite one. So it focuses on finding sets where all the vertices are connected to each other. So this is the maximum click. This is just the opposite, just a complementary example. So what will we do? We will make a maximum independent set problem with with the code in the next session. As you know, I like to um, divide the videos for the theory and the explanation and the video for the example of the code, just because some people may not want to see the video of the code and they want to go through the code alone or try them themselves. So we will do it using Network X. This is a Python library, but they are integrated in the Wave SDK, and this is a library that is specialized on graph theory. So they can be used to solve different problems, such as the clicks that we said before, graph coloring, solving traveling salesman problems that are some problems that in logistics, in all the transportation, they have like really so many applications. If you work in industry, I came across so many companies that start playing around with quantum with those kinds of problems, the traveling salesman problems. And they, of course, this library, of course, can be used for finding the maximum independent sets. So we will do that. We will use the maximum independent set um, function. So yeah, you will find the code on Moodle, and you will find how I do the implementation in the next session. So thank you for watching this as always. Any doubt that you have, any question, please feel free to reach me. Thank you.